Hello everyone, today I am going to present reversible cell injury, which is part of cell injury, cell adaptation and cell death. Now let's begin with the definition of reversible cell injury. Definition of reversible cell injury. This slide explains the definition of reversible cell injury. Reversible cell injury is a condition in which cells are damaged by harmful factors such as lack of oxygen, toxin, infections, or nutrient deficiency. However, the damage is not safe enough to cause cell death. At this stage, the cells undergo temporary change in their structure and function. One common example is cell swelling, which occurs because ATP production decreases and the sodium-potassium pump cannot function properly. If the cause of the injury is removed early, the cell can recover and return to their normal structure and function. Therefore, this condition is called reversible cell injury.
Neck hydroprictions, also known as cellular swelling. Hydroprictions is the earliest morphological change of reversible cell injury. It can return to normal if the cell receives enough oxygen again or if the cause of injury is removed. The mechanism is simple. When the cell lacks oxygen, ATP production decreases. As a result, the sodium-potassium ATPase pump does not work properly. Sodium and water enter the cell, causing the cell to swell. Finally, if the injury is removed, the cell can recover. However, if ATP depletion continues, the injury becomes irreversible.
Next, I would like to talk about fractions. Fractions is a reversible cell injury. This means the cell can recover if the cause is removed early. What is steatosis? Steatosis is the buildup of triglyceride inside the cytoplasm of cell. It happens most often in the liver because the liver is the main organ that processes fat. It can also happen in the heart and kidney. The mechanism is simple. When cells do not get enough oxygen or are damaged by toxin, they make less ATP. As a result, fat cannot be broken down normally. So, triglyceride build up inside the cell and from fat blockage.
Next, let's talk about bulbing of the plasma membrane. So what actually is a bulb? As you can see on the slide, bulbs are small balloon-like protrusions that form on the cell membrane. This happens when the underlying cytoskeleton gets disrupted, causing the membrane to bud out. Looking at the mechanism, it usually starts with ATP depletion. This failure leads to cell swelling and cytoskeleton damage. Eventually, the membrane detaches from the cytoskeleton, forming this blob. Crucially, this stage is a marker of reversible cell injury, meaning if we remove the structure, the cell can still recover.
Swelling of mitochondria. Mitochondria are responsible for ATP production through oxidative phosphorylation. Mechanism. So first it's gonna have hypoxia and then it's gonna reduce oxidative phosphorylation. And then it's gonna have ATP depletion and the water is going to enter into the mitochondria. And then mitochondria is going to be swelling. Morphological feature. Electron microscopy demonstrate 1. Enlarged mitochondria. 2. Mild swelling of the mitochondrial matrix. 3. Slight distortion of crystal. Because mitochondrial membrane remain intact and ATP production can recover once oxygen supply is restored. Significant persistent mitochondrial damage eventually causes irreversible injury due to the inability to generate sufficient ATP.
Next, I will talk about dilatation of the endoplasmic reticulum. The endoplasmic reticulum, or ER, is responsible for protein and lipid synthesis. It is one of the earliest organelles affected during reversible cell injury. Now, let's look at the mechanism. When a cell is injured, ATP level decreases, causing water to enter the ER. As a result, the ER cytidine dilates, ribosome detach, and protein synthesis decreases. Under electron microscopy, we can observe dilate large ER, loss of attached ribosome, and cytoplasmic vacuoles. These changes are reversible, so if the cause of the injury is removed, the ER can return to its normal structure and function.
Overall, reversible cell injury occurs when cells are damaged by harmful conditions such as hypoxia, ischemia, or toxic substance. However, the damage is still mild, so the cell can recover if the cache is removed in time. The hallmark of reversible cell injury is hydroprixene or cellular swelling. This happens due to ATP decrease, crashing cells of the sodium-potassium bond and leading to water accumulation inside the cell. Another common chain is fatty chain or steatosis, especially in the liver and heart, due to fat accumulation in the cytoplasm. Other changes include plasma membrane breaking, mitochondrial swelling, and dilatation of endoplasmic reticulum, which reduce cell function. In summary, reversible cell injury is the state where cell can still recover, but if the injury continues, it may proceed to irreversible injury and eventually lead to cell death. This is all of our presentation. Thank you for your listening.